Okay, this is 7.6, more work factoring trinomials. So these are going to go very quickly. In my notebook, I am writing this on page 126, and I think this will fit on just one page. So take a minute to read the whole page. This is all there is. 7.6, more work factoring trinomials. And then my star, it says, sometimes we are given directions that say factor the trinomial, but we must first undistribute before we can factor our polynomial into a product of two binomials. I like to call this skill undistributing before we factor. I just made that up. But some variation of that in my head has always been what I call this. So let's take a look at exercise 2. These are Kurt's examples, but I think you might find that I do things just a little differently. So the first thing I'm going to notice is I want to examine each of the terms, okay? So each of the terms, something jumps out at me. And when I notice that they share a common factor, that is the clue that I need to take out the greatest common factor. Okay? I want to take it all out. I want to take one thing or maybe a couple things out of each term. So we're going to call this the undistribute step. So first, undistribute the whole trinomial. Oh, that's not how you spell that. Undistribute. Okay, so what do I mean by that? I mean take something out that each term in the trinomial shares. So when I think of 10, 15, and 10, I think that the greatest common factor of those three numbers is going to be 5. Now, are there any variables that are shared among the three terms? The answer is no. So it's just a 5. Now I work it out. 5 times what number makes 10x squared? So that's 2x squared. Okay? And we keep using that process. 5 times what makes positive 15x? That's positive 3x. And one more, 5 times what makes negative 10? That's negative 2. So now we see that our trinomial is something that we're a little more confident with factoring. Now, unfortunately, it's still going to require us to use the method that involves factoring the first term and factoring the last term and trial and error, but it shouldn't be too bad because these factors of 2x squared and negative 2, there aren't tons of them. So let's get to that. All right. So now we're going to factor. And I'm going to write factor into two binomials. There are some parts that kids miss up here when they're doing this. Sometimes kids forget about the 5 out in front, so don't forget to bring that down. It's a 5. It's got to come down, but we're not ready to do that just yet. So let's think about 2x squared and the factors that make it. So that would just be 2x times x. Not too bad. And let's factor negative 2. So that's negative 2 times 1 or 2 times negative 1. Now that we've got that, we're ready to set up our binomials. Now, this is where kids forget about the 5. Remember to bring that 5 down because it's still part of the answer. Okay, so what will my binomials be? Well, we know it's going to be 2x and x. Those are our first times first terms. And now we need to choose, is it negative 2 times 1 or is it 2 times negative 1? So we have to do trial and error. Okay? So let's make these red. Negative 2 times 1 and 2 times negative 1. Let's try those out. Let's try the first one. -2 and +1. Okay, here we go. Outer times outer, positive 2x. Inner times inner, -2x. So hopefully you're looking at that and you're going, that's not it. Okay, because that does not equal +3x. Why +3x? We're trying to make +3x. Okay, so let's back it up. Get rid of only what we need. Now, it might not be -2 with the 2x, but I'm going to keep the -2. I'm just going to move it over here, and I'm going to try the +1 with the 2x. Let's check it out. This gives us -4x, and the inner times inner gives me +1x. Okay, well, this is promising, but this is going to give us -3x, so that's not what we want either. So now we know it's got to be, the signs have to be different. Okay, oops, so that was a 1, but we need our 1 to be negative. And, oops. So 1 has to be here, but it's got to be negative. And we need our 2 to be positive. Check it out. That's +4x and -1x, and that totals up to be +3x, which is what we want. Okay? So that is the answer. I'm going to box out the whole thing, the 5 and the 2 binomials, the whole thing. All right, let's move a little faster. Let's try this next one out. What can we factor out of all 3 terms? Well, 3 is jumping out, but I also noticed there's an x. So I'm going to take a 3 and an x out. I'm going to set up a big set of parentheses. And what's left? Well, I get x squared, and that means this is going to be a nicer trinomial to factor. This next term is going to be -7x, and this last term is going to be +12. So, why do I know this will be a little easier? Well, that's because look at the leading term of the trinomial. It's got a coefficient of 1. I can use the other method for this. So what I'm going to do is just bring that +12. Remind myself I need 2 numbers that multiply to get +12. And I need those same 2 numbers to also add up to equal -7. So I'm going to drag that +12 off to the side and list my factors. And I've got 1 and 12, and -1 and -12. And then I've got 2 and 6. But I start to get hunches that 2 and 6, they can't add up to 7. So I'm going to skip those. I'm going to do 3 and 4, and -3 and 4. -3 and -4. I skipped over 2 and 6 because I know that 2 and 6 do not add up to 7. There's no way. They either add up to 8 or they subtract to equal 4. So they can't be a possibility. And with that same thing in mind, that means I know 1 and 12 are out too. So you start to get a little faster at determining which factors you'll need. And once you get there, this will go much faster. All right, next step, factor into 2 binomials. So I'm going to rewrite my 3x. I'm going to set up my 2 binomials. And now I'm going to use my x times x to get my x squared. So that's my first times first. Now I just need to decide, is it 3 and 4 or -3 and -4? Now look off to the side. The answer when 3 and 4 are added makes +7. That's not what we want. Okay, when -3 and -4 combine, we get -7. That is what we want. So I'm going to circle those 2 numbers, and I'm going to use them in my binomials. -3 and -4. And that is my answer. Okay. Now down here, you notice it says write each of the following binomials in completely factored form, but it points out that these are binomials. So what I'm starting to think is that these may end up being a difference of two perfect squares once they're factored. So once we undistribute, let's use green again for that. So first, undistribute. Okay. And second, factor. All right. Here we go. So what can I take out of both terms? Well, we can take a 2 out. Now we take a 2 out, and we're left with x squared minus 9. And that's great because x squared is a perfect square, -9 is a perfect square. This binomial will result in conjugate pairs. Okay, this is the difference of two perfect squares, and it's going to result in conjugate pairs. So we're going to set up room for those two conjugate pairs. And don't forget about the 2. Got to bring that guy down out in front. Now we're ready to factor. So x times x. And what times what makes -9? It's got to be the same two numbers. -3, opposite signs, +3. Done. Okay, next one. Factor out what each term has in common. Not just a number this time, but a 5 and an x, which is great because now we have x squared minus. Now what's left on the -20x? That would be -4. Now again we have the difference of two perfect squares. This will give us conjugate pairs once we finish. So let's keep going. Rewrite the 5x. Set up the two binomials so that we have room for our conjugate pairs, and factor the x squared. Oops, that's not right. X times x, and then factor the -4, which same number, different sign. Same number, different sign. Done and done.